beaker or crucible supported on a ring, stand or clay triangle. And I think you have seen this during secondary school, but normally inside our lab right now we don't use this anymore. We'll use a portable gas one or hot plate. Okay, so for this one you need to adjust a mixture valve to get the right type of flame that you want. Okay, the second one, it is a hot plate. It function used for speedy heating up of any solution in container or under control measure. There is two button over here. One is for the heating temperature. The second one is for the stirrer. This is the oven used to dry a sample up to the 200 to 300 degree Celsius. Okay, so this is the application of oven. Okay, so inside our lab we have this type. Okay, this is the furnace. So let's say you need to get the high to heat the sample at the high temperature. Then you will use a furnace because you can heat up to 1000 degree Celsius. There is an furnace that can burn up to 3000. It depends. So normally for our lab, we have up to 1000 degree Celsius. And if you want to heat something less than 300,000 degrees Celsius, so you can use oven. Okay, so for water bath, normally you will heat not more than 100 degrees C because the body bath will boil water at 100 degree. So we will control the temperature, the maximum up to 99 degree Celsius. Okay, so the next one is a desiccator. So desiccator is used not for heating, but only for drying purpose. So it will prevent the reabsorption of moisture after oven drying and keep sample dry. If you have a hygroscopic sample, so it's better to put inside the desiccator. Okay. So the top of the desiccator should not be removed since the moisture from the egg introduced is rather slow and continued exposure will limit the lifetime of the desiccant. So if you want to use this, the top of the desiccator, you need to slide this. You cannot open it directly since we need to maintain the sample is dry. Okay, so it has a desiccator plate. Put your sample on top of the desiccator plate and we'll put desiccant at the bottom. The function of the desiccant is to absorb the moisture. It will trap the moisture particle to make the environment dry. We can use silica gel, calcium chloride, calcium oxide, or calcium sulfate. Okay, so inside our lab we are using a silica gel. If you are seeing a blue color silica gel, that means it's good. If you see that silica gel change to the pink color, it's not good. That means it has moisture inside the desiccator. Okay, so this is some of the commercial desiccant that commercially used. Okay, the part 6 is a titration apparatus and So for the analytical chemistry, this is the most important part, because normally we will use, most of the experiment is about the titration. So titration is a process which a standard reagent of known concentration from a burette, which is titrant, is added to a solution containing the analyte until the reaction between the analyte and reagent is judged to be complete. So how you want to judge it? We will have an indicator. So when the indicator change the color, that means the reaction is at an point. This is the proper technique for titration. Make sure you put your finger at the right position, because I've seen a lot of students doing a wrong technique of titration. So make sure you put your finger at the right, at the left side of the tab. Okay, so this is the proper setting for titration. Okay, titrant is in the burette, which is the concentration need to be known, and we will use a strong acid or strong base inside the burette. So in this example, it is a sodium hydroxide, and at the conical flask, this is the unknown content. Okay, so for this one, it contain a vinegar, which is the dilute solution of acetic acid, which is weak acid, and indicator. So if you want to know the reaction is complete or not, the indicator will change the color. Okay, so this is when you start to titrate the solution. As you can see over here, this is the wrong technique. So you need to use, just like I told you, that you need to start from the left side and put to the right, and uh, and you need to hold the tab. Okay, so this is the reaction. Then you will titrate slowly until you get the pink color. This is the equivalent point where the NaO is, this is the equivalent point reached when the volume of NaO use is noted, because there's a color changes inside acetic acid. So analyte in flask is non-volume mass. You need to determine concentration mass percent by reacting with the titrant, which is at the burette. Okay, so this is another setting that you can see. This is the stand, this is the tab, this is the tip. So make sure when you use a burette, please handle it carefully, because if you do not clamp it correctly, the tip will broken. Okay, so this is the meniscus reading. Make sure you are in the right eye position for the meniscus reading. So you need to see the change of the color. Okay, until finish this, until the titration is finished. Okay, so this is the right technique to hold your tab. Okay, the seventh subtopic is a filtration apparatus and also technique. Filtration is a technique used either to remove impurities from a solution or to isolate any solid from the solution. There's two types of the filtration used in the chemical laboratories, which are gravity filtration and vacuum filtration. For this also, there is how the you need a filtration and also vacuum filtration. For filtration, okay, this is the proper technique how to filter paper so that it will maximize the volume. Okay, this is the wash bottle contain distilled water to wash the precipitate. Okay, so normally we use the water to wash the precipitate, but make sure you know either the precipitate can be dissolved back with the water. If not, if it is a dissolve, it can be dissolved back with the water, then you need to choose another solution. Okay, you need to have a funnel. You can choose a funnel, normal funnel or Buchner funnel. Okay, so this is the filtration technique. So make sure you read this and understand it properly. Okay, this is the setup of the Buchner using a Buchner funnel, filtration using a Buchner funnel, and this one you can use a vacuum. As you can see over here, this is the part that you will put the pipe directly to the vacuum. Okay, so make sure the folded filter paper is fit to the funnel. Then you can drop a small amount of water so that it will attach to the Buchner funnel. Okay, then you can filtrate. You can start the filtration immediately and do not allow the water level to over the top of the paper. Okay, then transfer the precipitate to the watch glass. Okay, the part A is a chemical reagent. Okay, so for the chemical reagent, there is 4 types of the chemical reagent. First one, it is a technical or commercial grade. This one is the lowest quality of the chemical, which is not used. It is used for cleaning solution. And there's a cases that you can use this, but you need to do the distillation first to get the pure chemicals. The second one, which is that not commonly and normally have been used inside the lab, which is the reagent grade. This one is conformed to the minimum standard set by the Reagent Chemical Committee of an American Chemical Society. So this is the standard that we are using inside the lab. The third one is a primary standard grade. This one is quite expensive and it has a 99.95% pure. So for the titration purpose or as a standard, you need to use this because for preparing the dense volumetric solution and also the standard solution, you need to use this because it has a 99.5% pure. The last one is a special purpose reagent chemical. Okay, this one is is for specific application or for high-end instrument like for spectroscopic solvent and PLC solvent. This one is let's say the price for the ethanol. For this one, it can be about 2.5 liter, about 100 like that. But for the special purpose, maybe tell me about 1,000. Okay, there is a rules for handling a chemical reagent. So make sure you use the right techniques for handling a chemical reagent. So So we don't want that reagent bottle being contaminant. Okay, the last part is a cleaning glassware. So make sure all the glassware that you need to use, you need to clean properly. So this is a technique how you want to clean the glassware. Okay, so for burette and pipette must be clean so solution will flow freely and not beat up on the wall as the transfer is performed. For the volumetric flask, the neck must be clean to ensure the well-formed meniscus. Okay, so the cleaning method used to clean glassware, the first one, you can use a warm detergent. Okay, so brief soaking a warm detergent solution is usually sufficient to remove the grease and dirt responsible for water breaks. If the detergent is ineffective, then treatment with a cleaning solution usually help. Okay, let's say if using a warm detergent didn't work, then you can another cleaning method. The second one, you can use a dilute nitric acid. This is for films which adhere the inside the flask and the bottle may be removed by wetting the surface with the dilute nitric acid and followed by multiple rinses with distilled water. Certain case that your sample is adhere too much to your flask, so you need to use a dilute nitric acid to remove that. Or you can use the dichromate sulfuric acid cleaning solution. This is quite dangerous, so make sure you use you use the proper technique to handle it. Okay, this one, the good thing about this solution that you can reuse it again and again until you get the green color solution. That's mean after it changes to green color, it cannot do any cleaning anymore, so you can discard the solution. The fourth one is an aqua reagent solution. Okay, so make sure you handle it carefully because it made up from the three part of the concentrated hydrochloric acid and also one part of nitric acid. How powerful it is, it can dissolve a platinum, silver and gold. Let's say you have you need a gold material inside the electronic device, the waste electronic device, then you can use an aqua regia solution. Okay, this is some website that you can use how they are using the aqua regia solution to dissolve a gold. The last one then, ultrasonic cleaning. Okay, this one used for cleaning the glass cleaner, like to clean a pipette and burette. But unfortunately, our ultrasonic machine is so small, so it can only use to clean a small volumetric flask or the small thing only. Okay, so the glassware there's for ultrasonic cleaning, it is good to cleaning the burettes. Unfortunately, our ultrasonic cleaning did not fit for the pipette and burette, so we are using this for cleaning the dropper or the small beaker. Okay, the glassware is soaked in warm detergent solution, then through which is passed acoustic energy frequency at above 40 kilohertz. Then the ultrasonic vibration dislodge dirt and quickly from the glass 5 to 10 minutes. Let's say you are doing an extraction and the flask is dirty from your sample. If the warm detergent did not clean your flask, then you can use ultrasonic cleaning also. Okay, that's all from me for chapter 3. Okay, make sure you understand all of this and good luck. Thank you.